Greetings, acolytes of the celestial Emaxon. Have I got a present for you? In the beginning, Dslide had another name. It was macro slides, because of course in editor macros, the slides have to have keyboard macros, and now they do. Well, that's not so easy to read. Let's go ahead and fix that real quick. There we go, all better. They're hidden by default during a presentation, but I've turned the markup hiding off so we can see. I'll just start stepping through these. Keyboard macros is one of the two features that allows Dslide to encode anything that Emacs can do as part of a presentation. Whereas Babel blocks allow you to encode anything you can do with eLisp, keyboard macros allow you to do anything you can do with normal commands. I can control transients, I can turn on keycast, and as you can see, the input looks identical to as if I was controlling this myself using the keyboard. I did this session manually earlier, and then encoded it using the transcription tools I'm going to show you next. Right now I'm just pressing forward and can focus on communicating without being distracted by trying to type or correct typos. And when you compare that with other presentations where people are pausing a lot and thinking about how do I get from one buffer to the next to show the next piece of content, this is a much better solution. And because you record these by just using Emacs normally and building on top of the regular Kmacro tools, you don't need any more specialized knowledge and you can slow down and focus on getting the sequences right. That was fun. We used a macro to create the buffer, and we'll use a macro to clean up the buffer. So let's talk about recording. The first thing to know is there's a variable called last keyboard macro. It stores a vector of events that looks like this, and if we pass this through key description, we get something that's a little bit more human readable. But nobody wants to write this by hand, so I made a tool called DSlide Kmacro Transcribe. To demonstrate this feature, the next slide initializes with a Babel block that's going to show the source buffer where we are writing the macros down, and opens an org buffer where we're actually recording the macros. So first I'm going to move the point to where I want to record the macros, and then I'm going to run the command dslide kmacro transcribe setMark. It does what it sounds like. It sets a marker, and this is where the macro will be recorded. So now I'm free to go over to the source buffer, and I'm going to start recording a macro. And I'll create a title, and then when I'm done recording the macro, it's going to ask me to create a label. Make title is just the name for this step. So now the macro is recorded. Immediately, without switching buffers, I can start recording another macro. So I'll go ahead and create an org entry. We'll clown it up a bit just to make it a little more interesting. After I finish creating the entry, we'll give it a name, call it first entry. And you can see from this workflow how easy it is to create successive steps. We'll go ahead and create a second entry and go ahead and create a Babel block and put in some advanced eLisp. Finish up the code, stop recording the macro, and we'll name this one second entry. By now you've got the pattern. So let's say you want to support going backwards. All you need to do is take the buffer back to some previous state. So we'll record a macro, we'll give it a name, backwards, and then we need to set the direction to be backward. And then rearrange it so that it comes directly before the step that it undoes. So we'll step over it going forwards, and then if we step backwards, we'll run into it. To demonstrate this idea a little bit more completely, I'm going to go back to the very beginning, and we're going to record a macro that completely erases the buffer. So this takes us back to the beginning state, and this macro is going to be before all of the other forward macros. So if we back up completely, we can start back over. So now we have our macros recorded, and to reset everything I'm just going to go back to the previous slide and re-enter, and it'll recreate that org buffer. And if I start stepping through, we'll see, here we go. There's a title. There's a first entry. It was easy to record the macros, and now it's extremely easy to run them. When this second entry finishes, I can run the backward step and it will undo it. and I can rerun the forward step and it will redo it. So as you can see, this is a coherent sequence that we can traverse going forwards and backwards using idempotency. If we use the second backwards block we made to go back to the beginning, we can restart the sequence from scratch. We've made a traversable, coherent sequence that you could show to somebody multiple times, redemoing the same content until they get it. While that finishes up, take note of the Babel block before the macros and the other one after the macros. That's the setup and teardown for this slide. And there's the teardown, and now it's time to talk about what's improved about the Babel integration. And let's go ahead and turn KeyCast and ModeLine off. So less is more. In the early versions of Dslide, it was really verbose to get anything done. In version 0.6, the action is always on, so we don't need to declare it on the slide. Instead of declaring the direction with this ugly affiliated keyword, we now just use a regular Babel parameter. The default direction is forward, so in the best case, you don't have any extra markup. You can still use blocks to illustrate code, just set the eval parameter to never. There's a couple other values that are supported already, but if you think one needs to have a specific behavior, go ahead and file an issue. So how do we have a good time using Kmacros and Babel blocks together? Compared to Babel blocks, keyboard macros can really easily get out of control. They don't have any logic to look before they leap, they sometimes don't even fail, so they just keep going after they start making mistakes. And while you're recording, you need to be careful about things that look reproducible, but are going to change out from under you on the next run. Things like completions get updated as you keep using Emacs. The way that is supported and recommended for now is to go ahead and use Babel for your setup and teardown. By expressing logic, you can converge onto a very controlled initial state. To set up for a slide, you want to use the init block, or you can use begin and end separately. To tear down state, you use a final block. That will evaluate whenever the slide exits. Now, I need to do a little bit of work whenever we have child slides, but for now, if you don't have any child slides, it's very predictable. When is the final block going to evaluate? Whenever you exit the slide, either direction. This next bit of advice is about how to set up to use a terminal emulator that we're going to see in the next example. In order to do a good job, terminal emulators typically want to eat all of the input, but we need to control our slides, and that means that we don't want our dslide commands to be shadowed by the terminal emulator's key maps. In eat, the way that we set this up is we want to use semi-char mode, which doesn't eat all of the keys, and we want to add the events that we don't want shadowed to this eat semi-char non-bound keys. Then we want to run eat update semi-charred mode map to go ahead and generate the new key map. And then I'm not sure if this is necessary in the init or if it was only necessary while running, but you can run eat reload and it will immediately reflect the state the next time you open a terminal. So with the setup out of the way, what does it look like to integrate Dslide with the terminal? This example is a little bit cheesy for simplicity, and it pretty much just looks like a bash script. I used an init block and a little bit of magic with Dslide push step, and it runs a callback that splits the window and switches back to the source buffer and opens an eat terminal. This is an example of not only using Babel to do the setup, but to save what we need to consistently do the teardown. We want to get to a consistent final state. So in this terminal, I want to be sure that I have NAT server and the NAT CLI available, so I'm first going to load some Nix shells that will have those packages on the path. Nix is loading these out of the cache, so we're pretty much good to go. Our first real command is going to start up a NAT server, and then I'm going to save the PID so I can kill it later. We'll go ahead and publish something, but there's nobody listening, so we only see the published data. We'll create a subscriber, and then we'll save that PID so we can kill that later. This time when we publish, we can not only see the output from the server, but we can also see where the subscriber picked it up. The example goes on to publish twice more. I'm glad I'm not having to type this over and over. The remaining macros will clean up the server PID, then they'll clean up the client ID, and it's the Babel blocks that are going to restore the window configuration and kill the eat buffer. That is what it looks like to use a little bit of Babel to do your setup and teardown and use a bunch of Kmacros called against some arbitrary buffer. So what's up for 1.0? Most broadly speaking, we're going to continue having less markup that allows us to still do more. The custom programmability is also going to get easier while also doing more. The first priority is to take these two headline features, the Kmacros and the Babel integration, and make it where we can mix the steps from these two different actions. We want to be able to have Kmacros and Babel blocks sharing the same sequence. And right now you can kind of do this with the init blocks and the final blocks, but largely actions cannot have their steps mixed right now, and that's what I want to fix for 1.0. As a consequence of that work, it will become easier to have per element configuration. Right now, most of the configuration lives on the slide. In the future, if you need to have different configuration for each element, you can do that. And with a better system of default configuration, most of the time, we won't need anything. Because progress tracking is going to optionally move out of actions, actions can get a lot simpler. Instead of having to find the element and then work on the element, I'm likely just going to have to work on the element. And lastly, I want to make working with different buffers a little bit easier. Right now, I'm using a lot of magic to switch between buffers and to coordinate the slides and these other buffers, but I want to make this where everybody knows how to do it and it's easy. And the second thing is that I want to avoid this situation where we've got runaway buffers where you forget that you have a slide running, and then later on you start pressing some commands and all of a sudden, oh, I've got Kmacros emptying into my DURED buffer. So let's talk about how did I handle the playback and how do I usually try to handle timers. There are two sort of obvious ways to think about running a function in a loop with a delay. The first is that you can pass t as the repeat argument, and then you'll store the timer inside of a variable. And whenever the function that's being called decides that it's done being called, it will just cancel that timer. The second way, that's a little bit more self-contained, is that we will pass nil to the repeat argument, but inside the function that the timer is running, that function is going to call run with timer again, but it updates the arguments that it passes to subsequent calls. So the entire state for the state machine lives in the arguments. It's like a closure, and it just walks over its inputs. When it exhausts them, it declines to call itself again, which is equivalent to self-cancellation. Before I start calling the timer, I read the events from the buffer using read keyboard macro. This gives me back a vector of events, and that's what I'm going to feed in one by one inside the timer. And to actually fake the input, we just put the events into unread command events. If you throw a list of events into this variable, it's almost the same as doing input. And now for the last and most exciting topic. We are going to discover the hidden connections between keyboard jitter, the Greek nabla, the beast of possibility, and the magic of corporate brand identity. Our journey begins with the random jitter that I added to each keystroke. I didn't just use uniform randomness, I used a Laplacian distribution. It's that spiky distribution. The spiky part tends to produce typing that looks very regular, but then the long tails tend to produce these long pauses or these rapid speedups. And it's that jankiness that's actually why I'm very familiar with the Laplace distribution. One way to search through a gradient, even if you don't know the shape, is to just use a proposal distribution, and then you walk through each proposal. Now, if you use a Laplace distribution, it's very good at resolving local maxima, but it also doesn't get stuck in one place because of those long tails. Now, if you were to use a Gaussian distribution, that's a bad choice because it's very mid. It almost exclusively produces middling distances, and it's almost like trying to guess how far you need to go when the whole idea is that you don't know how far you need to go. Whereas the Laplacian distribution is like focusing on where you're at, but keeping an open mind to the far field. With those mid-Gaussian proposals, you'll never go anywhere fast, and you don't even know where you're at. The second piece of the puzzle is this Greek letter nabla. If you're doing the mathematics of anything physical, this letter just shows up all over the place, and it always tends to be in some of the most elegant solutions. In aerodynamics, if you have an incompressible flow, the divergence is 0, and if you have an inviscid flow, its curl is 0. Taking the divergence of the gradient is so useful that people just write nabla squared, and they call it the Laplacian. Our last waypoint takes place in UC 96, where everyone's trying to figure out what is their relationship to Kanase no Kemono, or the beast of possibility. And if you believe in the celestial Emacs and coming to save us from the software instrumentality, you have to believe in the beast of possibility. It's a story about the hope that was held even as humanity was cast into space. And even though sometimes things didn't quite go as well as planned, new generations didn't give in to cynicism or declinism or fatalism, because there are things that can't be changed. But even so, that can't change what we do. The embodiment of that hope was called the Laplace box, and so it should come as no surprise that my third level org heading is the Nabla. And it should come as no surprise that the basis for the PrizeForge logo is the right kind of randomness, a simple kind of elegance, and robots in freaking space. I like stuff, I hope you like stuff too. Support Positron and we'll make more stuff.
Whoa, not bad, partner. Follow me, I'll cover you.